Another thing that's useful to be able to do is to determine function families from tables and from sets of data. And so today we're going to look at how to identify linear functions, quadratic functions, and exponential functions from a table. Obviously, there are way more function families than that, but these are the most important ones to be able to identify from a table. So in order to test these values, one thing we have to make sure we do first when we look at these examples is we have to make sure that our x values are in numeric order before we begin, which just means that we want our x values to follow like 1, 2, 3, 4, 5, 6, like in numerical order. So we're going to make sure that that is true of our x values before we do anything else. Okay, so let's talk about linear functions. Linear functions, to be able to recognize them, they have what we call a common first difference. And a first difference means that just the differences between your y values are all going to be the same. Quadratic functions have a common second difference, which will almost look like a second layer of from our linear functions. And then exponential functions have what we call a common ratio, which is multiplication or division by the same number. So let's go ahead and do some examples of this. And for each of these tables, what I'm going to do is I'm just going to start with testing the first differences. Then if that doesn't work, I'll go to the second. And if that doesn't work, I'll go to the ratio. So first, my x values are in numeric order. That's awesome. So I'm going to test my first differences here. To get from 5 to 11, because I'm looking at my y values now, I would have to add 6. And then from 11 to 17, I have to add 6. 17 to 23 plus 6. And 23 to 29 plus 6. Okay, so those are all the same. So I have what we call a common first difference, which means this table represents a linear function. I'm going to do the same thing with my second example. My x values are all in order. So I'll test my first differences. 30 to 15 is minus 15. 15 to 7.5 is minus 7.5. So right off the bat, I can see that this won't be linear because my first differences aren't the same, but you are going to need a couple more numbers to test your second differences. So I'm just going to keep doing the rest of these. And you can always use your calculator if you're not quite sure how I'm getting these numbers. I'm just finding the difference or subtraction between these two numbers. All right, so let's go ahead now and we'll test our second differences. So for our second differences, it's just the second layer that we're going to be dealing with. So to get from negative 15 to negative 7.5, I would have to add 7.5. To get from negative 7.5 to negative 3.75, I've had to add 3.75. And then one more, I'd have to add 1.875. And so my first differences aren't the same. It's not linear. My second differences aren't the same. It's not quadratic. So the last thing I'm going to check is the ratio, which is going to be testing multiplication. So looking at my ratio up here, 30 to 15, in order to do that, I have to see if I multiply or divide by a number. So 30 to 15, that's a division by 2. And you can test that in your calculator. Just do 30 divided by 2. That should give you 15. And then from 15 to 7.5, well, that's another division by 2. And then from from 7.5 to 3.75, division by 2. And one more, division by 2. Perfect. So my ratios are all the same, which means they're common, which means that this represents an exponential function. Excellent. Let's go ahead and we're going to try a couple more examples. All right, so in these examples, I'm going to do the same thing. My x values are all in numerical order. I'm going to test my first differences. 2 to 10 would be plus 8. Oops. 10 to 12 would be plus 2. 12 to 17 would be plus 5. And then 17 to 5 would be minus 8. Okay, so my first differences aren't the same at all. Let's go ahead and try my second differences. So 8 to 2 would be minus 6. 2 to 5 would be plus 3. And then 5 to negative 8 would be negative 12. 13. I can do the math. It's good. 9 is 13. We got there. All right. So first differences are not the same. Second differences are definitely not the same. And so the last one I have to check are my common ratios. So 2 for my ratio. 2 times what would give me 10? So 2 times 5 would give me 10. And then 10, I don't exactly know what 10 times something would give me 12. I think it'd be times 1.2 technically. But I know that those aren't the same, regardless of what number that is. I know those aren't the same. And so this doesn't have a common first difference, common second difference, or a common ratio, which means that this is going to be some other family function. So you can just write other. And so we don't necessarily, it could still be a function, and indeed it actually is, but we just don't know what function family it falls into. And so if none of these work, you can just write other. Last but not least, we're going to check this last example table. So I'm going to test my first differences, which are going to be, so from -3 to -4 is -1. From -4 to -3 is +1. -3 to 0 is +3. And 0 to 5 is +5. And then none of those are the same, so I'll check my second differences. -1 to 1 is +2. 1 to 3 is +2. And 3 to 5 is +2. And that's awesome because all my second differences are the same. So our last example represents a quadratic function. If you would like some more examples of these, or if you have any questions, feel free to let me know.